These people, here in Mission Control, were responsible for guiding NASA's 1,800-pound unmanned Voyager 1 spacecraft some billion miles through space. On November 12th, after a 3-year journey, Voyager 1 made its closest encounter with the planet Saturn. Voyager has returned more than 18,000 photographs. Photographs that are giving scientists excellent close-up views and new information about the huge planet and its many moons. With the help of computer animation, you can take a ride on Voyager to Saturn and its major moons. Voyager's 11 scientific instruments probed deep into the atmosphere of Saturn and gave us an unprecedented view of those incredible rings. We now know there are 6 major ring systems, made up of possibly as many as 1,000 rings. The rings are sun-reflecting icy objects, ranging from boulder-sized to small particles that whirl around the planet at very high speeds. And those moons or satellites, like outriders, they encircle Saturn, generating as much scientific interest as the great ringed planet itself. Mimas, Tethys, Dione, Rhea, Titan, and a host of smaller ones. Next August, Voyager 2 will approach Saturn, pass by the ringed spectacle of gas and ice from a different angle, and then fly on to Uranus, arriving there in 1986. It may also travel to Neptune before leaving our solar system. From Earth, it appears as a warm, friendly ball, an integral part of everything living. But up close, it's a churning solar furnace that spouts solar flares in an atmosphere that's constantly changing and explosive. Little wonder that our star, the Sun, has been the focal point of scientific investigation for centuries. To relay sophisticated pictures and data about the Sun and its energy cycles, NASA launched the SolarMax in 1980, short for Solar Maximum Mission. Being returned are the first true close-up views of the mysterious spots and solar flares that energize the Sun's surface. All this part of an effort to learn how we can channel the Sun into an even more effective energy source. Closer to Earth, sounding rockets probe below where satellites orbit. And balloons carry heavy instruments that need a longer flight time than sounding rockets provide. Both play an important role in the scientific study of the Earth's atmosphere, everything from measuring the amount of ozone to gamma-ray radiation. Work on NASA's reusable space transportation system continued at many levels in preparation for the upcoming first launch. Practice recovery runs were made to retrieve the 2 solid rocket boosters that will be used to help launch the space shuttle. Just before going into orbit, the big rocket boosters parachute back to an ocean landing, where they are picked up and made ready for another launch. The shuttle orbiter's main engines have successfully passed firing tests, singly and clustered in a group of 3. They too are ready for launch. Installation of thermal tiles that protect the spacecraft from heat buildup during re-entry are now in place and ready for the flight. This is how the entire space transportation system will look. The airplane-like orbiter is attached to the main fuel tank with the 2 solid rocket boosters on each side. A new type spacesuit has been developed to provide an Earth-like environment as well as thermal protection from the sun. The advanced spacesuits have 3 basic parts: a body-cooling undergarment, a puncture-resistant pressure suit, and a life support backpack which contains 7 hours of oxygen and controls the suit temperature. This is astronaut Bob Crippen. It is he and John Young who will pilot the first shuttle flight. Since the shuttle orbiter glides back to Earth to an unpowered landing, It's important for the astronauts to have practiced these types of landings in advance. They do just that with a specially modified jet plane designed to handle and feel the way the shuttle does during final approach and landing. Crews are also training on this vertical motion simulator. It reproduces the motion an astronaut at the controls of the shuttle orbiter would feel during approach, flare, and landing without leaving the ground. Preparing for a busy shuttle flight in the years ahead, NASA selected an additional 19 men and women to begin training as astronauts, and that training is well underway. Many of the astronauts recruited earlier are learning to fly the Manned Maneuvering Unit, a compressed gas backpack that will enable the wearer to move around outside the shuttle in space on future flights. At another facility, engineers are working to develop procedures and hardware that will be needed for astronauts to build large structures in space. And they do it underwater, more than 1 million gallons of water, to simulate weightlessness. In space applications, the GOES-4 weather satellite was checked out and launched from the Kennedy Space Center, Florida. Weather forecasters and other scientists are using the satellite to study severe storms, flash floods, and tornadoes. This GOES East satellite picture taken last summer shows both Hurricane Allen over the Gulf of Mexico and Hurricane Isis in the Pacific Ocean. Ever since the spectacular eruption of Mount St. Helens, NASA has been working closely with other scientists to assess the impact. One of NASA's high-altitude U-2 aircraft sampled the air within 100 miles of the volcano. Recently, a plane from the Langley Research Center in Virginia flew a group of scientists and their instruments near the mountain. Among other things, they attempted to find out how much and what kind of gases come out of volcanoes. Worldwide, there's very little volcano data available. Energy from sunlight to power spacecraft is very important. Now, technology is being studied as a way to harvest thermal energy from the sun here on Earth. This is a research version of a solar farm. The dish-shaped concentrators are covered with mirrors, which reflect and focus the sun's rays to a point where the intense heat is converted to electricity. Rows of these collectors may one day help provide electric power for a small city or factory. It's part of a joint national effort by government and industry, sponsored by the U.S. Department of Energy. NASA's Lewis Research Center also worked with the Energy Department to develop this 200,000-watt wind turbine generator. Hawaii's strong trade winds blow year-round, making it an ideal location for electricity-producing wind machines. This one, which began operation last July, is located 45 miles north of Honolulu. 1980 was a busy year for NASA's various aeronautics programs. Consider this rotor systems research aircraft. These unique craft can be flown not only as helicopters, but also with wings and jet engines. The studies will investigate promising new helicopter technologies to improve performance, reliability, and safety. This strange-looking plane is the QSR-8, which means Quiet, Short-Haul Research Aircraft. It can land at speeds slower than many light airplanes, about 75 miles per hour, and can brake to a stop in 600 feet. In a cooperative test with the Navy last July, the QSR-A made 37 touch-and-go landings and 16 full-stop landings without the help of arresting gear or catapults aboard the carrier USS Kitty Hawk. This was the first time a 4-engine jet transport ever operated from an aircraft carrier at sea. In the future, the technology from the quiet-flying QSR-A. The XV-15 tiltrotor is another research aircraft that shows promise for both military and civil applications, including intercity transportation and for moving people and equipment to offshore oil rigs. The craft's helicopter-like rotors allow the XV-15 to take off and land vertically. Once airborne, the rotors tilt forward for cruise flight at over 300 miles per hour. The tilt-rotor concept achieves twice the range of a helicopter using the same fuel. Bridging the gap between wind tunnel models and full-scale aircraft is HiMAT, highly maneuverable aircraft technology. After being carried aloft by a B-52, HiMAT drops away. However, the pilot never leaves the ground. From here, he can fly the remotely piloted vehicle through any number of complex maneuvers and high-speed turns. This has proved to be an excellent technique for doing high-risk flight testing less expensively and with no danger to the pilot. This small jet-powered research plane takes off and lands like most aircraft. But in flight, it's unlike anything flying. The pilot of the scissor wing concept plane can pivot the wing up to 60 degrees, decreasing the air drag and making it possible to fly faster and farther without increasing fuel consumption. The AD-1 scissor wing has made several successful flights. At Manassas Airport in Northern Virginia, pilots have always landed with no help from air traffic controllers. But now, something new is in the air. It's an experimental automated pilot advisory system, APAS. NASA's Wallops Flight Center developed APAS and has successfully demonstrated it at the Manassas Airport in cooperation with the Federal Aviation Administration. As pilots approach the airport, they can turn their radios to a designated VHF channel, and a computerized voice tells them the location of all planes in the landing pattern. The FAA will now determine the merits of this and a similar automated system for possible use at many small airports around the country, adding a greater margin of safety for general aviation pilots. This special report brought to you by NASA, the National Aeronautics and Space Administration.